As we saw in the previous video, finding the sum of 2 points is fairly straightforward, but the algebra can be kind of messy. I'd like to show you some shortcuts that we can use in order to find the sum of points a little bit more quickly. First of all, I wanted to remind you about Viet's formula. A special case of it says that if we have a cubic, in other words a polynomial of degree 3, and we want to find its solutions, then the sum of the three solutions, x1 plus x2 plus x3, is always going to be the opposite of the coefficient of x squared, assuming that my leading coefficient is 1. So notice that if I already know two of the solutions, then I can get the third solution just by subtracting. So x3 will be the opposite of a minus x1 minus x2. So how does that help us? Let's say that we're working with y squared equals x cubed plus ax squared plus bx plus c. And we have 2 points, and we want to find out where the line through those points intersects the graph of this the third time. Well, we can go through the regular procedure of finding the equation for the tangent, or for the line through the 2 points p and q. We get something like y equals mx plus, I don't really want to use the letter b, so let me just say d, just use a different letter. And then I'll substitute that into here. So that gives me mx plus d squared equals x cubed plus ax squared plus bx plus c. Multiplying out this side, m squared x squared plus 2 mdx plus d squared equals x cubed plus ax squared plus bx plus c. So when I subtract, I'm going to get x cubed plus ax squared minus m squared x squared. So that's a minus m squared times x squared. And then I can subtract bx minus something else with x. And I can also take c minus d squared. And that will equal 0. The reason I'm scribbling this out is because I don't really need that. My third coordinate is going to be, the sum of the three coordinates, x1 plus x2 plus x3, is going to be the opposite of the coefficient of x squared. So that's the opposite of a minus m squared, which is equal to m squared minus a. So my third point of intersection has x coordinate, m squared minus a minus x1 minus x2. So now, notice that if we skip the algebra, if we skip some of this algebra in the middle, the only thing that we need in order to find x3 is the slope of the tangent line, so I will have to calculate that. I need the coefficient of x squared, which I can read from the equation, and I need the x coordinates at the initial 2 points. So let me write that down. Maybe up here. x3 is m squared minus a minus x1 minus x2. And now, let's redo the examples from the previous video. So let's say that P is the point -24, -96, and Q is 80. Then the slope is equal to 0 minus -96 over 8 minus -24, which is 3. So my x3, my third point of intersection, the x-coordinate, is going to be m squared minus a, notice that a is equal to 1, minus the first x-coordinate minus the second x-coordinate, which is 9 minus 1 plus 24 minus 8, which is 24, which is exactly the same thing we got before. Now to find the y-coordinate, it's helpful to write the equation for the line. So we have a slope of 3, and it goes through the point 8, 0. So y minus 0 is equal to is equal to 3 times x minus 8. So y equals 3x minus 24. So to get the y-coordinate, we end up substituting this x-coordinate 24 in. So y is 3 times 24 minus 24, or 48. So that confirms what we got last time. P star q is 24, 48. And then y3 we get by changing the sign of y. So x3, y3, the sum is going to be positive 24 and negative 48, which we have right here. So much quicker this way, much less algebra. Let's also see how this would work out if we were trying to duplicate a point. In other words, take 2 times a point P. We're still going to have to use implicit differentiation. So let me just go through that again. 2y times dy dx equals 3x squared plus 2x minus 720. So dy dx is equal to 3x squared plus 2x minus 720 over 2y. So the slope of the tangent line I can get by plugging in negative 24 for x and negative 96 for y. And just like before, if we simplify that out, we end up with a negative 5 as our slope. I think it's probably better to go ahead and figure out the equation for the tangent line now. So I have y plus 96 equals negative 5 times x plus 24. And simplifying as we did in the previous video, we get y equals negative 5x minus 216. Now let's figure out what x3 and y3 are. x3 is the slope squared minus a minus x1 minus x2. So that's negative 5 squared minus a is equal to 1 right here minus negative 24 minus another negative 24 because we're adding p to itself. So that's 25 minus 1 plus 48 plus 48, which is 24 and 96. 24 plus 96. Something's going wrong. Let's see if we can find it quick enough to salvage the video. So negative 5 squared, that's good. Negative 5 squared is 25 minus 1. Oh, plus 24 plus 24. That's it. So plus 24 plus 24 is plus 48. And 24 and 48 is 72, which is what we got before. And then plugging back into the equation for the line, y is equal to negative 5 times 72 minus 216, which is negative 576. And then we switch the sign to get y3, which is positive 576. So twice p is going to be 72, 576, just like we got last time.